Welcome to Learning Chemistry with the Professor's DuBois. Today, we will be learning about molecular and empirical formulas. Chemists are very interested in how molecules are constructed because that composition and structure helps explain the behavior of that substance. There are different types of molecular formulas. Some provide information about the structure, but all provide the number and types of atoms present. Element symbols have one capital letter, and some have a lowercase letter as well. The number of capital letters in a formula tells you the number of elements. The subscript following the element symbol indicates the number of atoms of that element. No number means 1. Covalent compounds form discrete molecules with fixed numbers of atoms and can have the same type of atoms combined in many different ways. These simple chemical formulas provide only what atoms are present. They do not indicate how the atoms are bonded together. A structural formula provides this information with lines representing the bonds between atoms. Writing or typing a structural formula is cumbersome, so chemists came up with a very handy condensed structural formula, where the structure is provided in segments on a single typed line, like this. Both of these describe the structure of the molecule in 2 dimensions. If one needs to communicate the structure in 3 dimensions, a wedge and dash or a space-filling model must be used. An empirical formula is a chemical formula that shows the smallest ratio of elements in the compound. An example of an empirical formula is NO2. This formula tells us that there are 2 oxygen atoms for every 1 nitrogen atom. The actual compound may or may not be NO2, but must be some multiple of this. Ionic formulas are the smallest ratio of ions that, when combined, are neutral. So the formula only tells what ratio of atoms are present, since the structure is a crystal that can grow indefinitely in all directions. Therefore, ionic formulas are always empirical formulas. Chemists have methods to determine the empirical formula of unknown compounds. If they also determine the molar mass, they can determine the actual molecular formula for that compound. For example, suppose you have the following data, and you need the actual molecular formula. We need to know how many empirical formulas are in the molecular formula. We need to know the factor. First, determine the mass of the empirical formula. From here, you could use trial and error to find the multiple. Or you could divide the mass of the actual molecular formula by the empirical mass to find the factor. Remember, the number of atoms of each element must be multiplied by the factor to determine the molecular formula. Pause the video and try these practice problems. Here are the answers. How'd you do? For related content, see our video determining an empirical formula from present composition. Thanks for watching, and please give us a thumbs up and subscribe for more videos that make learning chemistry easy.